Hi, I'm Oluwakemi. I'm excited to have you here again. This is question for the one JAMB Physics 2018, which goes thus. The dimension of electromotive force are. The formula for finding electromotive force is E, which is electromotive, equals to work done over, that is W, over charge. Okay, but we're going to break this down. All right, so let's start with the work done. The work done is equal to force times distance or displacement, as we know. All right, so we break the force further down. The force, remember, is mass times acceleration. Okay, then we still bring down the D. We're going to change all this into dimension as we go on. All right, then for the mass, the dimension for mass is A. Then for acceleration will still be broken down. Remember that acceleration is, the unit for acceleration is meter per second square. Okay, so the meter will be represented in dimension with L. Okay, while the seconds, that is, the unit seconds will be represented by T in dimension. So we have T minus, as in T raised to the power minus 2, okay, times the dimension for displacement is L. Alright, good. So if we look further, we can also see that we can still multiply through by L. So we have M L square T raised to the power minus 2. So we're going to use this, we're going to input that as a dimension for work in there. But before then, let us also solve for the dimension, or let us also figure out the dimension for charge. Okay, and remember that the dimension for charge, which is Q, is equal to current measured in, which is equal to current I times time. Okay, T. So that is the dimension for this. Then we're now going to impute that in the dimension for electromotive force. Okay, so now we have E equals, we represent, this will represent W. So we have the dimension ML square T minus 2 over, now this is the dimension for Q, that is IT. Okay, good. So now we need to simplify further. Okay, so the T raised to the power minus 2 will come down to the denominator. So we have ML square over IT times the T square. That is the one that came from the numerator. Okay, so we now have our final answer. Maybe not a final answer, but we're approaching the final answer. Okay, so we multiply through by T squared, so we have IT raised to the power 3. Alright, then finally we're coming to the final end. So now we have ML square. We need to bring the denominator up. Okay, so to that effect, I will be raised to power 1, then the T will be raised to power minus 3. So this is the dimension for electromotive force. So let's go to the answer option. Answer option B. Okay, answer option B is the right answer. It's just that the T is at the end there, while the T is at the middle here. So answer option B is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi and I'm excited to have you here again. This is question for the 2 JAMB Physics 2018, and the question goes thus. Which of the above are the correct SI unit of the quantities indicated? The first quantity indicated here is force with the SI unit N. Yes, the SI unit of force is Newton. This is correct. The second quantity, torque. The SI unit given here is Newton per meter. This is wrong. The SI unit for torque is Newton meter. Okay, so this is wrong. Alright, then the third quantity, current. The SI unit given there is ampere, and this is correct because the SI unit of current is ampere. Then the last quantity given, power. The SI unit of power is watt, and this is what as it is represented here. Good. So the quantities with the appropriate SI unit are 1, 3, and 4. So let's check the answer option. For A says 1 and 2, no. B says 1 and 3, no. C says 1, 2, 3, no. Then D says 1, 3, and 4. Yes, this is correct. So the answer option D is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question for the 3 JAMB Physics 2018, and the question goes thus. The resultant of two forces, 2 Newton and 5 Newton, is 13 Newton. What is the angle between the two forces? We're talking about the two forces 12N and 5N. Okay, so let us quickly take a quick look. We don't know if the angle between the two forces, we don't know what the angle is, so that's what we want to find out. Okay, good. So this is the resultant. So this is 12N and this is 5N, while this is 13N. So we have to find this angle right here. Okay, so merely looking at this triangle, this reminds us of the Pythagoras theorem. Okay, so and remember what this theorem said. This theorem said that the square of the hypotenuse, in this case which is 13, is equal to the addition of the two other sides of the square, the addition of the square of the two other sides of the triangle, which is what we have here. Okay, so if we simplify further on, 13 square will give us 169. Okay, then 12 square is 144, then 5 square is 25. So finally we have 169 equals 169. So if we have a triangle and it shows that the Pythagoras theorem applies to that triangle, it means that the angle between these two forces is 90 degrees. Okay, good. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 44, JAMB Physics 2018, which goes thus. Which of the following is not a vector quantity? A vector quantity is a quantity that has both magnitude and direction. And there are quite a number of examples, but it seems the option already has 3 of these. So let us check out which ones are vector quantity and which one is not a vector quantity. Okay, so option A says altitude. Altitude has only to do with magnitude, but has no direction. So altitude is not a vector quantity, but let's go through the other options to confirm. Option B, acceleration. Acceleration has both magnitude and direction, so it is a vector quantity. Alright, displacement also has magnitude and direction, so it is also a vector quantity. Then the last option, weight. Weight also has magnitude and direction, so it's also a vector quantity. So the quantity here that is not a vector quantity is altitude. So answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question for the 5 JAMB Physics 2018, and the question goes thus. A force F is required to keep a 5 kg mass moving around a circle of radius 3.5 meter at a speed of 7 meter per second. What is the speed if the force is tripled? Okay, from Newton's second law, force is equal to ma, okay, and the acceleration here is the centripetal acceleration, okay, which has its own formula. A equals v square over r. The v is the velocity, while the r, this is the velocity, while the r is the radius of the circle, okay, measured in meters. Alright, so we're going to substitute this equation for A in the formula F equals ma. So now we have mv squared over r, and this equation is the equation for the centripetal force. Okay, so now let us solve for the first. Let me do it on this side. So F equals m, the mass we're given is 5, okay, times the velocity, that is the speed, which is equal to 7. So now we have 7 square over the radius, which is given as 3.5. Okay, so 5 times 7 squared, 7 squared is 49, so we have 245 to be divided by 3.5, and if we punch that into our calculator, we have the force equal to 70 Newton. Okay, alright, then if we go to the question is what is the speed if this force is tripled? Okay, if the force is tripled, we're talking about 3 times F, okay, and we're still talking about the centripetal force. So let us just substitute the F in there. So we have 3 times 70 equals, the mass still remains 5 kg, then times the speed, which is what we are looking for now. It is unknown when the force was tripled. Okay, so we see have the radius as 3.5. So if we cross multiply now, we have v squared equals 3 times 70. Let us just put it to 10. 3 times 70 is 210, then times 3.5 to be divided by 5, and this will give us 147 if you punch that on your calculator. So if we square both sides of the equation, let me just move this slightly up. So we now have v equals the square root of 147. Let us bring out our calculator this time around. Okay, So the square root of 147 is 12.1 to one decimal place. So we have 12.1 meter per second. So that is the speed when the force was tripled. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye bye. Hello, I'm Oluwakemi. I'm excited to have you here again. This is question 46, JAMB Physics 2018, and the question goes thus. If a wheel 1.2 meter in diameter rotates at 1 revolution per second, calculate the velocity of the wheel. The velocity of the wheel V is equal to, it has its own formula, the angular velocity W times the radius of the wheel. Okay, and also note that in another instance the angular velocity W is equal to 2 pi over time. The 2 pi is the radian, which is the complete revolution per time. Okay, good. So now we're going to substitute this for the angular velocity in this equation. Okay, so now we have V equals 2 pi t times r, and we shall go ahead to put in the various values. Okay, so 2 times pi is 22 over 7, then the t, which is the time taken to complete one revolution. Okay, so that will be 1, so that is not included. All right, so now times the radius, and the radius is half of the diameter. The diameter given here is 1.2, so if we divide that by 2 we have 0.6. okay, so now if we punch the calculator, let's use a calculator. Let's quickly use that. So we have the calculator to do this. We say 22 times 2 times 0.6, okay, to be divided by 7. All right, so we arrive at 3.77 meter per second. That is the velocity of the wheel. Okay, so the answer option B is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 47, JAMB Physics 2018, which goes thus. A body of mass 4 kg resting on a smooth horizontal plane is simultaneously acted upon by two perpendicular forces, 6 Newton and 8 Newton. Calculate the acceleration of the motion. Let us have a quick diagram of what this question is about. So this is the horizontal plane, and let's say this is the body, and we said the body is 4 kg. Okay, then there is these two perpendicular forces acting on it. Let's say this is 6 Newton, and another one the horizontal, which is 8 Newton. Okay, and with this, only the resultant of the perpendicular forces, which is this, is acting on the body. So let's say that is F. And so to find this perpendicular, and so to find this resultant force, okay, which is the hypotenuse, and that is F equals to, according to the Pythagoras theorem, we have the square root of 6 square plus 8 square. Okay, so now we have F equals the square root of 6 square is 36, so we have 36 plus 8 square is 64, and this will give us 100. So the square root of 100 is 10. So the resultant force is equal to 10 Newton. So now that we know the resultant force, we can find the acceleration, and you know that force is equal to mass times acceleration. Okay, so now A is equal to force over mass, and the force we found is 10 divided by the mass, which is 4, and this will give us 2.5 meter per second square. Okay, so the answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm so excited to meet you here again. This is question 48, JAMB Physics 2018, which goes thus. The diagram above shows a plank RS pivoted its center of gravity O and is in equilibrium with the weight P and Q. If a weight 2P is added to P, the plank will be in equilibrium again by. So let us take a look at this diagram. We were told at the initial stage, this where the plank was at equilibrium. Okay, looking very closely at this diagram, it seems like the distance of the weight P from the center of the pivot is the same as the distance of Q away from the pivot. That is what it seems. So if that is the case, it seems that the weights are the same. The weight of P is equal to the weight of Q. Okay, so then the second instance is that a weight 2P is added to P. That means more weight is added to P. So in that case, we know that we're going to have a clockwise moment. And when a body is in equilibrium, the anti-clockwise moment is equal to the clockwise moment. Okay, good. So now how do we balance this up? So naturally or logically, you will see the plank is going to fall clockwise, sorry, anti-clockwise. Okay, and this will go clockwise, anti-clockwise as well. So how do we balance this up? We will need to shift this weight closer to the pivot. Okay, and in another case we may have to shift the Q farther away from the pivot. Okay, so it is either in those instances we either shift the weight, the extra weight of the P towards the pivot, or we shift the weight of the Q away from the pivot, farther away from the pivot. So let us look at the option to see which one might fit into our description. Option A says moving Q nearer to O. Moving Q nearer to O? No. In fact, that will even make it to be more unbalanced. Okay, so option A is not correct. Alright, option B, moving P nearer to O, that is the pivot, exactly what we said, because P is now more weighted, so it will need to move closer to the pivot in order to maintain equilibrium. Okay, so the answer option B is the answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Enquiry. I'm so excited to have you here again. This is question 49, JAMB Physics 2018, and the question goes thus. Which of the above conditions must hold for a body acted upon by a system of three coplanar forces in equilibrium? For forces to be in equilibrium, it means that they are balanced. Okay? And coplanar force systems have all the forces acting in one plane. Okay? So I would like us to quickly go through a summary of the characteristics of a coplanar force system. One is that the lines of action are coplanar. That is, they are in the same plane. Alright? Good. What about the other characteristics? Another one is that the lines of actions are convergent. That is, they intersect at a common point. Alright? Then lastly, the third point that I want to look at is that the vector sum of these forces is equal to 0 vector. Okay, good. So now let's go to look at the conditions given in the question. All the three forces must be concurrent. Of course, all the three forces must be concurrent, which means that the lines of action are convergent, and which means that they intersect at a common point. Okay, good. So this condition is favorable. Alright, the second condition, the upward force is equal to the downward force. This does not correspond to the characteristics of a coplanar force system. Okay, then the third condition, the algebraic sum of the moment about any point must be 0. Of course, we just highlighted that the vector sum of all these forces is equal to 0 vector. So this condition is also correct. So we have condition 1 and 3 correct. So let us look at the option. Option B is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hello. I'm Oluwakemi. I'm glad to have you here again. This is question 50, JAMB Physics 2018, which goes thus. What is the frequency of vibration if the balance wheel of a wristwatch makes 90 revolutions in 25 seconds? The frequency of revolution is the number of revolution in a unit time. Okay, good. And so frequency is equal to 1 divided by the period which is required to complete one revolution. Okay, and also take note that the SI unit for frequency is hertz. Okay, that is Hz. Alright, good. So now let us calculate the frequency of revolution when we have 90 revolutions. Remember, the one which is the number of revolutions, now we have 90 revolutions, okay, over the period. What time does it take to run this? It takes 25 seconds. Okay, so now we want to divide 90 by 25. So 90 divided by 25, this will give us 3.6 hertz. So this is 3.6 hertz. Alright, so the answer option D is the right answer. Thank you for watching. See you in the next video. Bye bye.